Hi, Kat here for Lightwave Digital. In today's video, we're going to be talking about how to take some of the older assets that are floating around out there in the world of sci-fi meshes or Foundation 3D or wherever you might get some of your fandom models from to do hobbyist work or even little fan films or just to study them. Over the years, Lightwave has been used extensively for this kind of stuff, as well as for building production show models that they've seen in many series, including Star Trek Next Generation, um, Deep Space Nine, Voyager, Enterprise, you name it, Battlestar Galactica, Stargate SG-1, and Star Wars is no different. Um, although most of the Star Wars stuff has been hobbyist based, there's been a lot of fantastic work done with it. But some of these models are quite old. I have a model here that I believe this came from Andrew Cook, or Andrew Crook, and this was done originally, I think, back in 2003, and this was done with the old shading system, probably in Lightwave 7, maybe 8. So what we're going to do is we're going to give this a little bit of a facelift using the new shader systems, so we can kind of bring them up to somewhat modern methods, but still try to maintain the look of this ship as best we can. The other part of it is that we're also going to take a look at how this model is organized and how the image sets are actually quite suitable because they were done properly in the first place, even years ago, for transport over to Unreal if necessary. So let's take a look at that right now. In this folder, I've got images, so we'll take a look at this. Nothing really scary here. We've got some normal maps. We've got some additional maps for our droid, the R2 unit. We've got our pilot, normal map for the pilot, the fuselage, normal map for the fuselage, specular map, wings color, normal map for the wings, and of course a specular map for the wings themselves. So nothing really scary in here. This is actually, a pretty good set of maps. We can do quite a bit with this just to begin with. Let's go over to the objects. We've got our wings split, wings flight. We'll see what that looks like once we get into the scene editor in a bit. And then we've got our scene scale. Now this was the original one. I've packaged this for 2023. I haven't done any modifications to it, however. Still the same set of images, same set of objects, and same set of scenes. The reason for this is I just want to make sure that I've got the original and I don't overwrite anything and damage the original asset, because I could still take this into Lightwave 2015 or an earlier version, play with it in there, do other things with it that might require going back to the original and remodeling it or something of that nature. So I don't want to damage it. So that's why I've packaged it over to another folder. So this was the original scene scaled. Now I've got a scene in here called prep, and this just basically gives me a single light in here that's a distant light. So that's our key light, and this key light is very basic. It's just a key light with a shadow angle of 18 degrees. We can knock that back actually to 2 degrees right now for the moment. And we've got an enviro light. This enviro light is actually what's giving the ship its blue tinge because it's using the Hosek Wilkie physical sky model. Okay, and we've got a rad figure light, which is a DP dome light from Dennis Pontonier. This is just another method of me giving kind of like a radiosity look, because I'm not going to be using radiosity in this, just at least for the moment, because I don't need to. Just a simple ship, not a big deal. And we're going to be looking at textures for the most part. So I want something that effectively will let me light the ship properly and give me an idea of what's going to look like under all types of lighting conditions. Years ago, people were always concerned about, well, will the ship look good in space? Will it look good in desert environment? Will it look good on Hoth? And sometimes people would adjust textures because they weren't using a physically based renderer or texturing system to do that, and you put them in one environment versus another environment, and things would kind of go kind of wonky. So let's take a look at this with VPR, and keep in mind this is just with the original base textures. Nothing's been done to it whatsoever, so it doesn't look too bad. Let's just go to this frame here. We'll go and take our object and we'll reset its distance because I had it flying around. So there we go. And we'll move ourselves over a little bit. And we'll also grab this camera or this light and we'll move this over just a little bit so that we can see where it is in the scene very easily. So for now, what I'm going to also do is I'm going to turn off the visibility of these other two lights because I don't really need to see them in the OpenGL overlay. But it's handy to see where the distant light is so we can check it for, how it's splashing light across the ship and we see where the specular hits are, that sort of thing. Okay, so what we've got here basically is just a straight imported version of an old model or asset that's 20 possibly years old, using the old shader system. It doesn't look too bad in here, but we can certainly give it an upgrade. But let's take a look at what lighting is doing to this. And we'll also turn off the environment light just so we can see what that looks like without. So just in terms of how that specularity plays off the ship, it's not bad. Could use some improvements in a little bit of places because metal is generally pitted. There is a little bit of pitting in here. The normal maps are applied in a very odd way though, so we're going to have to fix that. And I think our bump maps are also either inverted or they're not set correctly. Because really there isn't a bump map. It's a normal map that's incorrectly used. Although when normal maps were first introduced into Lightwave, we had a shader specifically for it rather than a node. And some people would just plug the normal map into the bump map channel, and that's not how it works. So this is not appearing as good as it should. But if you go back to the original image that we had, didn't do too bad in the old shader system. So let's get this thing looking very spiffy. But we can see how the light plays across the nose. This is good. It hits up in the little specular highlights in there in the scrape section, but it could certainly use a little bit of life to it. So I'm going to just pull this light down a little bit more. Okay. All right. So let's go and check the image editor and see what we've got for images. Now, this is gamma adjusted. Somebody did the gamma adjust in, pre insertion into the product. So it's already been adjusted for color space, but because we're working in the system that allows for that to be done inside of the software, we may have to fiddle with this just a little bit. Let's take a look at what our color space settings are right now. Now, I've already done this as a preset, but originally it would have come in like this. And this is not far off, but we want to make sure that we're working in the proper color space all the way across the board, and then we'll adjust our images in here to get back to where we want to go. Okay, so let's flip that. Okay, so this is gamma adjusted. Let's turn that back down to sRGB. Okay, just to make sure that it's in the right spot. Okay, these should effectively be set as they are, or we can set them to linear, but this is something that we're going to have to do a comparison look-see at. So let's go sRGB for that. Yeah, so it's staying where it should be. Okay, let's make sure that this is set to linear for our normal map always. Okay, it seems a little bit washed out because it was probably pre-adjusted. So we'll set it back down to default. That looks a little bit better. This needs to be set to linear, and I think we will also set that to be linear, and we should be in the spot here where this makes sense. We need to change that one more time. Okay, so now that we've got the maps kind of sorted out here, it's time to take a look at what the surfaces are. Now this was done with the standard shader or the standard layers system years ago. So if we want to make this into a physically based shader or set it up for Octane or something like that, we're going to have to use nodes, which is not a big deal. Don't worry about that. If you're used to the layer texture system, it's not as complicated as people sometimes make it out to be. It's actually quite simple. But we'll notice in here right off the bat, let's shift click in VPR to that fuselage. We got a bump map in here, and it's using this, which is incorrect. This is not where a bump map goes. Even years ago, this is not where a bump map goes. In Lightwave 2015, if you have it, it used to be under the shader tab, and there was like a normal shader specifically for it, or you would use the node for it. So we're going to immediately go to that, and we're going to just disable it in here so it's not doing anything funky. And we're going to go and change this texture. We're going to convert it to a principled nodes system. And we'll hit the edit node graph, and I'll have to pull it into here. We'll do a little bit of screen rearranging here because screen real estate being what it is with these editors open, sometimes it can be a little bit cluttered, but keep in mind, I don't normally work off of one monitor. I work off of 3 monitors, and there's a very good reason for it. So, first things first, this bump is not a bump, so we're going to disconnect this, okay? And we're going to take this luminous color out of here. That shouldn't be in there. Okay, we're going to go over to the editor for all these settings here and just rewire stuff as we go. Okay, so this is the original standard shader. We can minimize this and leave it off to the side. Doesn't need to be anywhere except for where we want it. We're going to disconnect this. Okay, and we're going to go and sort that normal map out first. So we're going to go take normal. Okay, double clicky, and we're going to go and grab that normal map. So it's fuselage normal, and it's on UV map set 1. Okay, and we're going to pump that normal map into either the surface or into the shader itself. Okay, now this one, sometimes you'll see maps where it'll come in and it'll look kind of funky. You might have to invert the Y on this. In general, this seems to be okay coming in as is, but you see this weird kind of phenomenon here where it's like flipped backwards. So it seems that this one is also going to be inverted. All right. So we'll work with that. And now we've got this kind of color map is in here. We don't have any specularity or roughness on here that's significant. We're going to crank the roughness up to, I think, 60%. And we're going to use this specular node, which is the specular map itself. And we're probably going to pump this into, let's go in an invert node. Okay. And we're just going to see what this does as a roughness value override. And then we can take the original output and pump it into specular. Now let's take a look at what happens here when we rotate this light. Seems kind of okay. Nothing really knocking my socks off just yet. So let's change this order. So we'll take that to specular, and we'll take this one to roughness. And now you can see that we've got a slightly different look here. And you can see that there's a nice glint off the front of the nose. And when we wipe by with the light, it gives it kind of a nice impression that there's metal underneath of this paint. Let's just move that light over a little bit more so you can see it better in terms of its direction. Okay. Now that map itself is okay, but let's say we wanted to give this even more kind of an improved look. Another option here would be, instead of going with Principled BSDF, would be the car paint node. I actually set this up as a preset, so I'm going to go and load it. Boom, hit open, and now you can see big difference there. Although I did make one error in this before, and that is in the normal map. It needs to be inverted, I think. That looks better. So now it looks like there's, some really nice metallic kind of properties to this paint, and it should look pretty awesome under most lighting conditions. But to check that, let's turn that light back on, our environment light. So we'll minimize this for a second, get rid of all that. Okay, get rid of this, go back to our scene editor, and hit that environment light. So yeah, it works. It's not doing anything scary, and we can see the breakup of all the paint and everything else. Now, what's doing that? Well, in the car paint node, I have basically just recycled certain maps that we already have. I didn't have to go and create new ones. I just plugged them into various spots that made sense. Our scalar layer, which is that fuselage spec, it's inverted. I inverted it again, put it into paint roughness. I probably could have just avoided that and gone direct, but I needed it for the principal BSDF node version, so I just left it that way. Okay, making sure the normal map is plugged in correctly, but it also has the normal map feeding the paint normal, and this specular map over here is going straight into paint specularity. Nothing crazy. It just helps it come alive. There's a little bit of flake density change and some clear coat specularity and roughness values that are plugged in here instead of the defaults that help make that pop. So let's go back to our perspective view. Let's go 50 and 35. So you can see the subtle change there. It really comes down to what you know your preferences for the look. But just using the original maps that somebody created, if it was Andrew Crook, well done on the maps, because they still hold up and they're not huge at all. They're very minimal in size. They could probably stand being fed through some kind of AI blower upper image resizing tool that we now have access to. But you can see just how nicely this plays out. Okay, so now that we've done that, I want to adapt it to the rest of the ship. So we're going to now take what we've done on the fuselage here and adapt it to the wing. Very straightforward. There's a little bit of manual work involved, but for the most part, we'll just be able to copy this surface, and I'm going to just right-click it and pump it right in over top of this. Even though this is going to totally screw up all the other settings that were in here, it's fine because we're just going to go through and edit the nodes for this and rewire things as necessary. So go in, and there's our principal BSDF shader. So let's go and hit the preset or load the surface. Okay, so we're going to go fuselage, boom, and that'll come in like so. And we'll see that all the maps are screwed up, but that's fine. This will be quick work just to go through and change them. So instead of fuselage, we're going to go wings. So that first one is the color texture. There we go, wings, boom. That sorts that problem out there with that. Then we need to do our scalar maps. So wings. This one is the spec map, and we also have another one here, spec map. And we've got one more with the normal map. That should bring it back to where it should be. Now I did adjust the light there a little bit, so that kind of changed the look on us for the second really quickly there. But now we've got something that's consistent. It's also the car shader. We've got it also on the ship fuselage. But that's only wing one. We've got to do some other wings. Let's close all that down. And we'll go to our surface editor. All right, and we're going to save this one out. Wings car paint. I'm going to call this 2023 version. Okay. And we'll copy this. Copy. Bang out as number 2. And this will need us to probably look closer and examine the ship to make sure that it's actually all in the right spot. This might have a different UV map, but I think this all worked out okay. Let's go to the bottom side of this just to make sure. Looks to be okay. Let's take that key light, shine some light on the subject, and it seems to be okay. All right, so now that that's done, really the only stuff that's left is um, part of the other wings, whichever that might be. Let's take a look at what that is doing. Those wings UV set in general 1, yeah, okay. So we should pretty much be able to go copy and pop it on there. Boom, just to make sure. Then we've got our astromech. Now this could be a little bit different. He might have his own UV set. No, he's UV1, but he's got different maps entirely. So let's go and paste that in there. We'll double click on him to edit his maps, and we'll switch him to his appropriate textures. So first off, color. You are an astromech, so you need to be color gamma adjusted. It's always great when people label their texture maps and they're easy to find and go through. So this is going to be astromech spec, okay, and this is also going to be spec. Yeah, there's that one, and this one. And then of course our normal map for him. No, he doesn't have one. Interesting. Okay, so what we're going to do with this case is we're going to disconnect the normal map from this. We'll just go and take a look at what that looks like at the top. Because if he doesn't have a normal map, we don't want something else wired into it, doing strange, bizarre things to his skull. So what we're looking for here is any problems where he's got a smoothing group issue or something similar. So if he doesn't have an actual normal map for himself, let's just check to see if he was included in one of the other maps for the normal map. So that's just him. Let's go to the fuselage and take a look at this normal map and see if we can spot R2. See if he's in here anywhere. Doesn't seem to be. So we'll just leave him disconnected and we'll just have to let that be the way that it is. Okay, so now we've got that sorted. Okay, let's close all that down. We'll also save him out as well, but we're going to disconnect this normal map first. So paint normal, don't need that, and don't need that. And this may solve that little smoothing problem. No, it doesn't, unfortunately. But that's okay. We will live with it. But we'll save him out as well, just as a material. So, boom, 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 boom. Save surface. Okay. All right. So what is blank? We don't know what blank is. There's probably nothing in here. It's just that color. Okay, I guess we'll leave that. There's nothing in here. This blend other standard. I don't know what that is. We have to find that somewhere in the modeler application to surf that one out. But here's the pilot. Now the pilot, obviously, because he's through glass, we're not going to be able to see him very much. But I am going to convert him to a principal BSDF shader. Okay, and that conversion pretty much should have just worked right off the bat. We're probably going to have to go in here and redo a couple of things because this is not a bump map, it is a normal map. So let's get that sorted out first. Invert normal map. Okay, bump, bump. And that's going to go there. And check though to see if this is one of those. No, this is also still. Nope, that's the wrong one. We'll click that. This is still UV set 1. So we will use UV set 1 on UV set 1 for the normal map. Okay, so pilot normal map. Okay, I'm going to invert it and UV set 1. Okay, there we go. So normally I like to wire this stuff for normal maps directly into the surface because this also affects OpenGL. So I can bypass this. It's in the wrong spot in the first place. And make it look like that. And then we're going to get rid of luminous color. We're going to take his roughness value. We'll put it up to like 70%. And we'll leave that there. Now, I don't think he has a specular map specifically for himself. We'll have to check that. I don't think there is one. So let's go to the image editor. No, he is just basically color, gamma adjusted. So we can take in a jiffy just the luminance values for this effectively and pop that into specular, but we're going to tone it down using multiply tool. Okay, so we'll pop it into there. We're going to turn it into the specularity, and we're going to give the multiplication like 0.1 or 0.5 or 0.15, and that should do it for the pilot. Now, it's going to be a little difficult seeing it through the glass, but he's in there, he's doing his thing, and now he's just proper material. Idea being is that we want to eliminate any of the standard material shaders in here because when they're used in combination with the physically based rendering shaders, this essentially is an emulation of the old system. And when the renderer is doing checks to see if that's there, you can slow the renderer down by saying, hey, is this shader being used in some way that's going to impact these other shaders, because it has to switch back to that emulation mode in the ray tracing engine, and that can slow things down. So we effectively want to eliminate all of these if we possibly can. So let's just convert this to principal layered nodes. And we'll do the same thing over here. Let's take a look at this. This is transparency. This is for the glass. So this is good. Let's go and rename this. Just make sure it's the glass. Yeah, it's the glass. So we're going to rename this cockpit glass. All right, and we're going to flip this to principal nodes. Okay, and for this, we're definitely going to improve this look. We could probably go to 98%. Pop that down just slightly, probably 95%, 91.5, a little bit. Okay, and we can leave that almost basically as an air polygon, which is what the refraction index of 0 or 1.0 should be. But we're going to pop a little bit of clear coat on this, just 15%. Just give it a little bit more life, and we're going to turn that gloss down to like 10. Okay, and if we double side this, you'll get some interesting render results going through, so it should properly work if you got a background in there. We don't want to go overboard with this. We make this a little bit more transparent, I think. Let's keep going, 94, 94, 94, 95, 96. And maybe we'll turn the double sided off just for now. No, we'll let the double sided on. Okay, so that takes care of that. And maybe we'll pop this up to like 50%. And let's take a look at what happens when we rotate that light on there. What's going on with the cockpit? So we can definitely see through him. He's got some specularity on his helmet. That's good. He's kicking back some light through the glass. All right. And this is one of those things where, depending on what you're doing with your shots, if you want to be able to see your characters moving their heads back and forth or doing like hand signals or something like that, you may want to wire a value like that transparency up to a null so you can turn them all very transparent, or adjust them individually without having to go into the surface editor to do it manually. That's a technical direction kind of instruction that I would offer out there to people that kind of want that control. It depends on what you're doing, but if you've got only one ship in the shot, it's very easy to go in there. But if you've got dozens of ships in a shot, you might want to wire the one up, make sure that materials, ready to go for everybody, and do it that way because it'll save you a heck of a lot of time. So now that we've got this thing in here, all of their surfaces have effectively converted. This is starting to look where it needs to, at least for the physically based shading system, as it's understanding lighting and it's interacting with the light on the ship. But let's see what this starts to look like when we change the environment lighting, because this is the idea behind this exercise: is will it look the same when we start playing around with different types of environment lights? Because we want it to be on Hoth, we want it to be on Dagobah, we want it to be somewhere on Yavin or something similar. Let's go to the environment light here. Okay, now we're going to change this. We're going to remove that, and you can see right away that just its own lighting, because I don't have the other light on in the scene. Okay, so if I turn that off, it's just basically picking up and kicking back the light from the original key light, and that's it. Okay, so we can see all that nice breakup on the surface of the ship. That's all great, but now I want to see what it looks like with the different types of environment lighting. So let's turn that environment light back on. We'll turn the key light off, and let's try this with something different, like a textured environment. And we're going to go and edit that texture environment. We're going to pop a HDRI in here. Okay, so we're going to go spherical, and we're going to go and grab an HDRI, which is going to be fun. We're going to go to my production archives, and I'm doing this off screen because there's some stuff that's in these directories that I can't show because these are all shows that I work on. So give me a moment, and I will fetch an HDRI. Something nice, something pretty. Let's try something in here. Something that people are familiar with. There's the Blur Loft, for example. This is a very well-known HDRI that's pretty much shipped with every single program for the last 15 years, or somebody's included it with the ship and it's just going to be there automatically. Let's make sure that its texture axis is correct, and let's also make sure that it's in the proper color space. Yep, it's good to go. Okay, so now that that is in there, is this reacting properly to that environment light? I believe it is. It doesn't look like anything is out of place in terms of color response or how it's reacting, but let's turn on the effect specular of that light and see if that's also working properly as well. And I think it is. This looks like an X-wing to me out of the movie, depending on how weathered it would originally be. Its surface is reacting very nicely. Let's get rid of some of these panels here so we can take a closer look at what things are doing. We don't need maps. Okay. So yeah, that's effectively how this would perform. We'll go into this texture environment editor here and just really quickly rotate the texture. Let's see what that looks like with 180. Yeah, very spiffy. Okay. That's the beauty about the environment lights and the DP dome lights, is that their radiosity, kind of like a background radiosity effect or background global illumination effect, with the ability to throw specular lighting at the same time. Fantastic stuff, because radiosity normally is just radiosity. It's just diffuse. So having the option on that panel is fantastic. Although it would be great if we could just get this so I don't have to hit 180 or 90 degrees in the editor. I could just rotate the light. It'd be great. Because it's an environment light, though, that really has no bearing on a scene where it's placed in it or how it's rotated, though I can see why they didn't do that, but it'd be really cool if I could just go link rotation or something like that. We could do that through other means, but right now I think this works good. So here we are. We've got our Happy astromech there. Doesn't look too bad. Let's turn on that key light again. Okay. And even though we'll be kind of doubling up what's going on with this light, oh, let's not do that one. Let's go with the key light. And I will take the center off. And we'll just have a fiddle with this to see how these surfaces are now reacting. Looks pretty good. Nothing's crazy. It is a little bit overblown because we're doubling up on two sets of lights here. But adjust the taste, dial things back, do what you need to do. Get that environment light, back down to like 50%. And now we're a little bit more realistic. Again, this really should be off, and just let the key light go in there. It depends on how you're lighting your scenes. Now, for real space look, Star Wars was very hard lit in space. There weren't a lot of fill lights everywhere. It was very, very hard key light space look. Same thing with Battlestar Galactica. Because in space, really, you've only got one, maybe two bright sources of light. And, if you're in a binary star system, you can have like two suns, kind of like on Tatooine. Or if you've got a situation where you've only got one bright light source, you're only going to really have that key light and then a little bit of fill for starlight, or just bounce off of the atmosphere from a planet that might be nearby. It's going to be extremely minimal. So let's try to make this look a little bit sexier, more like it would for space. I'm going to put that to 10%, maybe even less. Let's go 5%. Okay, let's take this key light now and rotate this puppy so that it looks more in line with something that would be in deep space. And we may have to adjust some of the values of the other light just to help it out. Backlighting, running across the surface of the ship is also a really great technique, depending if that works for the dynamics of your shot. But you can see here, if we go through the camera, let's take that camera, find our ship. Let's go 0. All right. Let's go to the other side and take a look at it from a more dramatic angle. And we're going to go turn the grid off. So hit D for that, and go and turn that grid off because it's distracting right now. All right. So there we go. That's something that's a little bit more in line with dark space lighting. Your sun would be way back here. If you want something a little bit more dramatic, like the Yavin shot, then it'd be something a little bit more like this. Possibly like that, where they're flying from Yavin 4 towards the Death Star. I think I've got that angle somewhat correct. And then if we want to fill in the blanks here with that environment light, so we can kind of see a little bit better inside of these engines, this is where you would have to dial things in. But ultimately for that, you would want multiple bounce radiosity using the radiosity function in the renderer, or using the DP dome light that'll allow you to do the same thing via occlusion. But let's turn this up a little bit and see what we get. So we can just brighten that up just slightly. Oh, that's really a lot. Let's turn the specularity on just to see what it does. Just gives it an extra little bit of light and life to it. Let's dial it up. Like 15%. So we can see just a little bit in the darker shadow areas. And then, again, if you want, this is the alternative. Let's take a look at what the rad figure light does, which is the DP dome light. These are not currently publicly available, but they hope to return very soon. Let's go to occlusion here, and I'll show you what this does. Max limit basically is the limit that the light exists everywhere, and then it detects whether or not there's a polygon and says, hey, you need to be less illuminated. So if I extend this, it's going to pay less attention to smaller details. So let's go like 10 meters, and we'll turn off the other light so we can see this being more dramatic. Let's turn that key light off. Okay, and we need to turn this up to something like that. So you can see that there's just barely anything in there at 10 meters because it's evaluating out to 10 meters. And then if we pull it down, you'll start to see the insides of the engine cowlings illuminate. Let's pump this up a little bit more so we can see what we're doing. So you can see it just brightens it up on the inside a little bit. Of course, this is obviously too bright, but we can pop that down. We can counter it by reducing this to like 100 millimeters. And that pulls the lighting back up. So let's turn the key light back on. Pop. And there you go. Depends on which way you want to go. Different ways to light things. You can turn that icon preview off if it's distracting. But let's take a look at what this does with just regular radiosity. Let's turn off the DP dome light and look at the renderer. Let's go to render properties. And we'll go to global illumination. We're going to turn on GI. Now this is basically just using this key light. It's not evaluating anything in the background because that background that we put in, which is the HDRI, is actually coming from the environment light itself. For this to work, we need basically to tell the radiosity engine that there is something in the background, and that's going to be a little bit different. So let's go to the background options. Okay, where's my background options window? Stuff's everywhere. There we go. Okay, so we're going to add an environment for this. So we can go backdrop, double click it, and we'll just go to big gradient backdrop. Now, this seems to be having issues right now because this scene came in from a very old Lightwave scene. And sometimes what's necessary is you've got to eliminate that environment light and then reload it, and it'll fix it that way. Let's see if we can get it to come back to life though. By going to our environment light, properties, okay, and we're going to re-enable it in the scene editor. Okay, it doesn't seem to like it there. We'll turn that off. Let's go use global, bump. So now it's picking up the gradient in the backdrop. So let's change this from backdrop. Let's remove that. Yeah. Okay, so it is more or less working. Let's go back to texture environment. Spherical. Let's put that HDRI in there. And now we've got something that's working with just radiosity. Let's turn the key light off to test that. The environment light shouldn't be black. So what we need to do here, I think, is load a new light, environment light. Okay, there we go. Boom, fix that problem. Okay, effectively all that is just confusion between how the old lighting system worked when we loaded this original scene in and not updating a couple of things. So that's fixed. So this is what the light would look like, effectively working properly with that background and the environment being evaluated for radiosity. So if we turn this off, it's just going to use that environment light. Okay, now if we turn the environment light off, so that environment light is now off. So it is just actually just using that background now. So the rad test off, boom. Let's go and re-enable GI. Does it want to play nice? Not this time around, I don't think. Let's turn that environment texture light on. It still doesn't want to play nice. Oh, it's because I got no lights on. There we go. Okay, so this basically gives us. Oh, I don't want to clear all lights. Uh, that backdrop in there now. So we're using global. If we turn that off, it's now using the texture environment that I've loaded already. But because we're using the same image, it's just one's rotated, one's not. So that's how that's working. We can see just how nice that looks. Um, for the most part, that concludes this video. But we need to save this out so people later on can check it out. Special thanks to the artist who originally made this. I believe it's Andy Crook. Go check him out. He is still active in the Lightwave community. I see him around quite frequently. So say meow and all that. And thank you very much, Andy, for letting me use this without your permission, because I have been offline for a number of days. So I couldn't get a hold of you, but I'm sure that's all fine. Let's take a look at that light though with this re-enabled. And see just how scrumptious this looks with it sweeping across the nose. Yeah. So that's the power of being able to recycle the maps from older models and giving it a little bit of a facelift with the new shading system that came along in Lightwave 2018 and has been improved since. And the combination of the physically based renderer and just a couple of tricks to recycle those maps. So you can take something that was an asset that was built 20 years ago and pop it into the modern Lightwave and get right to work. Ultimately, if I was doing this just on my own without trying to tell you guys what I was doing, I could have had this asset ready in less than 15 minutes at the most. And this little dude back here, he looks pretty good. He actually looks like he's more or less there. Let's turn the OpenGL display off here. And there we go. And you can see just how quickly this renders. There's the other camera position. And that was rendered pretty much with one set of anti-aliasing steps and 16 refined samples. Very, very fast. Let's go 100%. A little bit noisy in some of the spots here, but that will be cleaned up through a couple different means. A little bit of adaptive sampling improvement and some motion blur, of course. And there we go. All right, that concludes this video. We'll see you again very shortly.